Hello and welcome. Today, we're talking about steel. It's everywhere, in our buildings, cars, appliances, truly the backbone of modern life. But there's a huge environmental cost. The traditional way of making steel relies heavily on coal, making the industry responsible for a staggering 7 to 9% of global carbon dioxide emissions. That's a massive chunk. But change is coming, and it's called green steel. This isn't a new type of metal, but rather steel made using processes that dramatically cut down or even eliminate carbon emissions. The goal is to move away from the old, polluting blast furnaces. So how do we make steel without the massive carbon footprint? Several exciting technologies are leading the way. The frontrunner right now is hydrogen direct reduction, or H-drive. Instead of using coal, specifically coke derived from it, to strip oxygen from iron ore, this method uses hydrogen. The chemical reaction changes completely. Instead of producing CO2, it produces simple water vapor alongside the iron. This resulting iron product is then typically melted in an electric arc furnace to make steel. The crucial point here is that for the steel to be truly green, the hydrogen used must also be green, meaning it's produced using renewable energy like wind or solar power. Another fascinating approach, though perhaps further from large-scale deployment, is molten oxide electrolysis. Picture dissolving iron ore in a special molten mixture at very high temperatures, and then passing an electric current through it. This directly splits the iron oxide into liquid iron and pure oxygen gas. If powered entirely by renewable electricity, this method could be virtually emission-free. However, it faces big hurdles, especially in finding durable materials for the equipment and scaling it up affordably. We also should forget about improving existing electric arc furnace routes. These furnaces primarily melt scrap steel, which is inherently much less carbon-intensive than making steel from raw iron ore. Using recycled steel is a major way to lower emissions. Powering these EAFs with 100% renewable electricity cuts their carbon footprint dramatically. Innovations are also focused on enabling these furnaces to use a higher proportion of direct reduced iron, especially the green kind made using hydrogen, alongside scrap. Lastly, there's carbon capture, utilization, and storage, or CCUS. This isn't about eliminating emissions at the source, but rather capturing the CO2 produced from traditional or modified steelmaking processes. The captured CO2 is then either stored deep underground or used in other industrial applications. It's often considered a transitional technology or a way to handle emissions that are particularly hard to avoid. Of course, this transition to green steel isn't straightforward. These new technologies, especially those needing green hydrogen or involving novel electrolysis, currently cost more than traditional methods. We need massive investment in new infrastructure. Think wind farms, solar panels, electrolyzers for hydrogen, and transport networks. Taking promising pilot projects to the scale needed for global industry requires significant engineering breakthroughs and capital. Furthermore, supportive government policies, maybe like carbon pricing, and increasing demand from customers for low-carbon steel are essential to drive this shift forward. So why does all this matter so much? Decarbonizing steel production is absolutely critical if the world wants to meet climate targets like those set out in the Paris Agreement. It provides a pathway for heavy industry towards sustainability. It could even create new markets and advantages for companies and regions that embrace the change early. This shift to green steel is more than just an environmental necessity. It's a profound technological and economic transformation that is reshaping one of the world's most fundamental industries for a sustainable future. It will require collaboration across the board, from steelmakers to energy providers, technology developers, policymakers, and indeed, all of us as consumers. Thanks for tuning in.